Hello and good day, everyone. My name is Teacher Christine, and welcome for today's lesson. The topic we're going to discuss is all about motion exploration. We have a set of objectives to target this day. First is to describe how motion takes place in a particular object. Then trace and measure the time and distance of an object in motion with respect to its reference point. All right, what is the topic all about? Very good. It is all about motion exploration. Today we're going to discuss the third quarter first day lesson, which is all about motion exploration. Are you ready? Very good. Let's have first a warm up. Tell whether the picture shows us a push or a pull. And the answer is a push. Very good. This time, the picture shows us a push or a pull. And the correct answer is a pull. Very good. Next, on this picture, it tells us a push or a pull. And the correct answer is a pull. Very good. Look, what can you see on the screen? Very good. A map. Yes, it is. There is a map over there. What is it? A school science center map. On the map, what else do you see? Very good. Let us study together the map below and answer the following guide questions afterwards. Okay, on the map, we can see directions. Very good. Directions pointing to the north, south, then from the east to west. Aside from directions, what else do you see? Very good. The main entrance door. A single door on the main entrance. Starting in front is a stick person. A stick person standing over there in front of the main entrance. Alright, what else do you see? Very good. There are different rooms to go through. Can you name all those rooms under the school science center map? Yes, we can. What are those? The information desk, the library, the earth and the space room, the audiovisual room, the laboratory room number 1, and the lecture room. Now, can you move to a certain place by just looking at the map? Yes, we can. By the way, what do we do to go through the different rooms in the school or the different places cited on the map? Can we? Yes, we can. By the way, what shall we do to keep moving? Very good. We can keep moving by walking. Yay, high 10. All right. If we are going to make a label, what should be our indicator to help us find the shortest and fastest way to get there or in going to a specific place? Do you have any idea? All right. Very good. We can put an arrow over there. By just putting an arrow, this is the best label we can do to make things easy in going to a specific place in the school. On this page, we're going to name the locations cited on the map. Everyone, please read. The information desk, the library, the Earth and Space room, the audiovisual room, the laboratory room number 1, and the lecture room. What will help us move without losing our track? Very good. And the answer is following direction that points out from north to south and from east to west. We can't lose our track by following Direction. Very good. Which room is the longest way to get there? And the answer is the lecture room. Very good. Which one is the shortest? The information disk. Good job. This page, you will be asked what causes motion? And the answer is movement. Again, what causes motion is our movement. Good job. I'm going to define the difference between motion and force. Motion will always be part of our daily living. Everything we do involves movement. What causes the motion of an object? What stops an object under motion? The answer is force. Thus, force and motion are interrelated to each other. Let us understand the meaning of force and motion and their relationship. Motion is relative. It is a change in position with respect to a reference point. In other words, it refers to the movement of the body. It can be described as change in direction and change in speed. Reference point is a fixed place or an object used to determine the position of an object. Through it, one can tell whether an object has moved or not. Force is defined as a push or pull that can affect the movement of an object. Look, what have you seen on the screen? Very good. There is an illustration right there. Yes, it is. There are two illustrations of situations flashed on the screen. Again, what is it? There are two illustrations of situations happened before and after the motion was done. I want you to compare the situation. Bear in mind that the pushcart serves as a reference point. We are only dealing with one pushcart. Remember, again, we are only dealing with one pushcart, which serves as our reference point, which filled with balls inside, and that pushcart stays still. Again, look at diagram number 1. It shows that the balls change its position with respect to the pushcart, which serves as our reference point. The balls move by taking them out from the pushcart, meaning from the reference point, which is our pushcart, the cart stays still without moving. Why? It is because we don't apply force from it. That is why it is not moving. We set it as a reference point. However, some balls were taken out from the pushcart. This is where motion is applied. When we took them out from the pushcart, we use movement. Look at diagram number 2. It shows that the balls didn't change the position with respect to the pushcart. However, the pushcart changed its position with respect to the ground, which serves as the reference point. The cart moved by pushing it against the ground, meaning with the aid of the person applying force to the pushcart, pushing it towards certain direction, the pushcart changed its position. The cart moved by pushing it against the ground. However, the ball inside the cart didn't change its position. Yet, by applying force to the cart changes its position. Look, what have you seen on the screen? Yes, an illustration again. Look at diagram number 3. What does it tell you? Can you tell your observation to anyone else right here watching over? If yes, then what is it? Alright then, there is a stick person right there, holding a cart, pushing towards a certain direction. What else do you see? Alright, that stick person might move either between places, from the reference point moving to lane A forwarding to the cashier, or from point A to point B to C. From the point of reference going to point B, then going ahead to C, corresponds certain measurement in terms of meter as a unit of measure according to the length of path it covers. Now, we will be talking about distance and displacement. Alright, so distance and displacement are different quantities, but they are related. Distance is an important factor in measuring motion. In measuring distance, it is important to have a standard unit of measurement, as we have seen on the screen, and should be measured using the appropriate tools such as roller, meter stick, measuring tape, measuring wheel, and ultrasonic distance measurer. Let us find out the difference between the two. Alright, what is or what do you mean by distance? When we talk about distance, what is it? Distance is the measure of how far or near 2 points are from one another. It is the complete length of the path between any 2 points. Back to the illustration. Look at diagram number 3. Okay, what is the unit of measure used? Right, to complete the path between 2 points. All right, meter. Okay, meter is used as a unit of measure in measuring distance. Diagram number 3 shows that the total distance from point A to point B, which measures 2 meters, and from point B to C, which measure 3 meters, and from A to C, 5 meters, with a total distance of 10 meters. Again, what is the total distance in between? Yes, it is 10 meters. However, displacement is the change in position of an object. It is represented as an arrow that points from the starting position to the final position. Displacement is the direct length between any 2 points when measured along with the minimum path between them. Look at diagram number 4. It shows that pushcart moved from point A to point B, then the object position changes from the starting position of which the cart can be found before it was moved. The cart has been set up to lane A as its starting position, then was repositioned to the cashier as its final position. Now the direct length of path is called displacement. Now, we will be talking about speed and velocity. Look at the picture. What have you observed? We are seeing simple map or location from home with one-way ride of a school bus going to the school. Let us understand the difference between speed and velocity. When we talk about speed, what does it mean? Speed is how fast something moves. It can be calculated by dividing the distance covered by an object in motion by the time it spent to cover the distance. Speed is measured in terms of meters per second or kilometers per hour. However, velocity is speed with direction. It is the rate of change of the object's position with respect to a frame or time, a frame of reference in time. Look again the diagram. Diagram 5 shows that the distance traveled from home to school is equivalent to 6 kilometers. Again, how much is the distance traveled from home going to school? Very good, 6 kilometers. And the time is equivalent to 3 hours. What is the time it is equivalent? 3 hours. Thus, the speed is equal to 2 km per hour and the velocity is 2 km per hour east. To get the speed, use the given formula. Look, what is the formula of speed? Speed is equal to distance over time. Note, there can be no motion without force as it influences the movement of a certain object. But in the case where some object moves through uneven surfaces, the distance covered by a moving object is affected by its speed, or the measure of how fast it moves. The faster it moves, the shorter time it takes to cover a certain distance. Inversely, the slower it moves, the longer it takes to cover the same distance. You can tell how fast or slow we are moving depending on the distance that you are taking. No matter how fast the moving object is, it takes time to travel from one place to another. Let us remember the things that influences motion exploration. When we talk about motion, what does it mean? Motion may be defined as the change of object's position as caused by force with respect to a reference point. The position is where the object is located or the object can be found. The change in position is dependent upon time. When talking about reference point, it is a fixed place or an object used to determine the position of an object. Force initiate and influence motion. A moving object can change its direction when acted on by a force. The distance covered by a moving object is affected by its speed or the measure of how fast it moves. When we talk about speed, speed can be calculated by dividing the distance covered by an object in motion by the time it spent to cover the distance. It is expressed as speed is equal to distance over time, or S equal to D over T. Distance should be measured by using measuring tools such as the ruler, meter stick, tape measure, measuring wheel, and ultrasonic distance measurer. The faster the object moves, the shorter time it takes. This time, let us check how far you have gone through with motion. For our assessment, I want you to read the questions with me, then carefully choose the best answer and write it on a clean sheet of paper. For number 1, which of the following demonstrates motion? A. A boy jogging in place. B. Dog barking at the garage. C. A girl running towards his father. And D. A boy running on a treadmill device. And the correct answer is letter, are you ready? Letter C. For number 2, how can a biker travels a great distance in a specified time? A. Pedal slowly to decrease the speed of the bike. B. Pedal faster to increase the speed of the bike. C. Increase the distance it will cover in the same time allotment. And letter D. Pedal faster to increase the time it will take to cover a distance. Are you ready? The correct answer is letter B. Number 3. Which of the following actions can cause an object to move from one place to another? A. Pushing. B. Singing. C. Sitting. D. Sleeping. Alright. The correct answer is letter A. Pushing. For number 4, how can you tell that an object is in motion? A. Object changes its position from one place to another. B. Object is at rest in a certain position. C. Object moves in the same position. Letter D. Object changes its time at one place. Are you ready? And the correct answer is letter A. Number 5. Which of the following initiate and influence motion? A. Position. B. Force. C. Distance. D. Speed. And the correct answer is, are you ready? B. Force. Number 6. Which is the reference point of a boy leaving home for school? A. Canteen. B. Classroom. C. Home. D. School ground. Are you ready? And the correct answer is letter C. Number 7. What is the importance of point A in determining the movement of the object? A. Point A determines the distance of an object in motion. B. Point A determines the initial position of an object in motion. Letter C. Point A determines the final position of an object in motion. And letter D. Point A determines the speed of an object in motion. And the correct answer is letter, are you ready? Letter B. Alright, for number 8. A car traveled 30 kilometers for 2 hours. What is its speed in meter per second? A. 4.2 meters per second. B. 8.4 meter per second. C. 15 meters per second. Letter D. 30 meters per second. Are you ready? And the correct answer is letter C. Number 9. A jeepney travels 120 kilometers in 3 hours. What is its average speed? A. 40 kilometers per hour. B. 43 kilometers per hour. C. 60 kilometers per hour. And D. 120 kilometers per hour. And the correct answer is letter A. Alright, for number 10. Describe the speed of the runners based on the given distance time graph next to. A. The slower the runner is, the longer it takes to cover the same distance. Letter B. The slower the runner is, the shorter time it takes to cover a certain distance. Letter C. The faster the runner is, the longer it takes to cover the same distance. And for letter D, the faster the runner is, the shorter time it takes to cover a certain distance. And the correct answer is, are you ready? Letter D. All right, thank you so much for bearing with me throughout the discussion. See you again. Bye bye.